In this video, we're going to introduce the fundamental concepts of scientific programming in MATLAB. If you have previous experience programming or with MATLAB, feel free to skip this video and move along to future videos in the series. When you start MATLAB, this is the screen that is going to be displayed. On the left-hand side, under the current folder, shows the directory or folder that you're working in. On the right-hand side, you see this Workspace tab. That is the region in which variables will be displayed by their name and value. The primary window that we're going to be concerned with is this interactive command window. Now, we should note that anything that is written in this command window will not be saved to a file, which is one of the reasons if we were to be writing a true MATLAB program, we would want to use a script. Now, a script is just a file with a bunch of commands that is run through MATLAB and will produce an output, pretty much like a program. What the command window allows you to do is to immediately interact with MATLAB in order to maybe familiarize yourself with a data set or become more familiar with a set of MATLAB functions that you might not be used to. So now that we have the basic layout of the screen understood, we're going to introduce the fundamental concept in programming, which is variable declaration. Now, if we think back to our previous coursework in mathematics, we all know what a variable is. A variable is a symbolic representation of some value. Now, in this case, when we're dealing with variables in a programming sense, we want to expand upon that definition. In math, we're used to having a variable take on a single value. In programming, variables can take on numbers, words, or even entire operations. So we really want to have a strong foundation in understanding what variables do in programming. So the first thing is for us to realize that a programming language is not like a graphing calculator. It's not interpretive. It doesn't know what x is if we don't define it. For example, if I just say x, we say that it's undefined. The computer doesn't know what to do with it. So when we're programming, we have to essentially break down our problem into steps that we tell the computer explicitly what to do. So the first command that we're going to learn is this clear command. Now, what the clear command does is it clears all variables in our workspace. Because there's nothing there, there's nothing to clear. Another similar command to clear is CLC, which clears the screen that we're working on. If I press CLC, everything in this command window is cleared and I have a blank slate. Okay, now let's get started in programming our first variable. So going back to math class, let's say we have x and we want x to take on the value of 3. If I press enter, we see that the computer outputs x is equal to 3. Now, the first thing in MATLAB I should say is that we always want to think about the efficiency of our programs. We don't want every time a number is called or a variable is declared or a whole array of numbers saying that contain 1,000 numbers to be displayed every time we want to do an operation to it. So what we can do is we can prevent the computer from displaying the output of a given variable by following that variable with a semicolon. So let's say I have y is equal to 6, semicolon. We see on the right-hand side that our variable is stored, but it did not display in the output. Now, MATLAB is just like a fancy calculator. We could do x plus y, and we have an answer displayed as 9. Now, it should be noted that even though this is stored as some arbitrary variable answer, if I do, say, x plus 3 times y, it's going to be replaced by whatever output it is. So when we're dealing with new operations or creating new quantities, what we want to do is always define a new variable. So let's define a new variable z, and let's say that this is 5 times x plus 2 times y. And we don't want the output displayed, so we're going to follow it with a semicolon. And voila, we have what z is. Okay, so this is the pure foundation of programming in which we declare variables. Now, right now, this isn't particularly helpful, especially if we want to solve kind of involved, complicated problems. So let's take a deeper look at different variables. So I'm going to clear my screen and clear my workspace. So let's start off with a new variable that I call 3. Now, this variable a is a number, and specifically, it's an integer number. So the computer stores this value as an integer. If I say b is equal to 3.7, this number is no longer an integer, it's a decimal. So the computer stores it as a floating point number. Now, right now, you might not understand why a computer will store, numbers differently, but in later videos, it'll become apparent, especially in terms of the efficiency of calculations. But right now, take my word for it, is there's a reason why that the computer would store 3 differently than 3.7. The next type of variable that we will encounter is a string. Now, a string is given by a variable that's declared within quotation marks. And a string is a word or a phrase, or even you could have a number inside of a string, but then that number doesn't act like a number anymore. It acts as some kind of word. We're not going to be dealing with strings too much in MATLAB because, again, it's not a true programming language, rather an analysis tool, but strings do come up in the context of uploading data and having to navigate through and essentially clean up data sets. And we want to be aware of that. At times, these data sets will be labeled with titles that MATLAB will interpret as strings, in which case we'll have to do something special with them. And again, so here we have someone's name is equal to Bob. Okay, so right now, let's recap. We have 3 different variable types. We have an integer, a float, and a string. The last variable type we're going to be dealing with is the most useful. The reason why we have computers is to automate repetitive tasks. So for example, let's say I wanted to count from, 1 to 10. I could say, A is equal to 1, B is equal to 2, etc., etc. But that's not very useful because it's storing each of these numbers as a separate variable. So again, clearing my screen in my workspace, we want to have a way of representing multiple sets of numbers. The first one is relatively simple, and the first one is what we call a vector. Now, a vector, for those who have experience in physics, is something that has both a magnitude and direction, In this case, we're not dealing with that physical thought or physical representation of what a vector is. Essentially, you can think at vector as a one-dimensional set of numbers. So if we had 10 measurements of, say, a drop time of a ball, if we wanted to store those values in a table and put that table into a variable, that variable would be size 1 because we have one observation, or one quantity that we're observing, i.e. the drop time, and 10 observations of that quantity. So to define a vector in MATLAB, the first way is to create a variable, let's call it vet, and create an open bracket, and let's have a vector of the numbers 1, 4, 6, 8. If I press enter, we see that we have this new variable that's going to display each of the numbers within those square brackets. Now let's say we wanted to have a variable that included all the numbers from 1 to 10. We could say, new vector is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And sure enough, we have that, but that's not very efficient. We should have a way of being able to just create a set of numbers in one instance. And we can do that with MATLAB's colon operator. So let's say we have, say, m is equal to 1 to 10. Now this colon is going to tell MATLAB to create a vector that starts with 1 and goes up to 10. If I press enter, here we go. We have the same thing as we were shown in the variable new vector, but much more concisely. Now we can also specify the iteration, or rather the spacing between each number. So if I wanted to say n is equal to 1 to 10, but I wanted to go up by, say, 2, I could say 1 colon 2 comma 10, pressing enter, and I get every other iteration. So I get 1, 3, 5, 7, and 9. Again, these are all stored as a list of numbers that we call a vector in MATLAB. Now, there's going to be two more things we're going to want to discuss in this video. The first one is how to deal with operations in MATLAB involving vectors. So if we're doing a scalar operation in which, say, we want to take each vector, each element in each vector, and do something to it, say multiply by 3, we could do 3 times n, and we get the result. Now, it should be noted that this is a scalar operation. So just like if you were to think about any type of vector algebra you had, when you had a vector defined by a set of coordinates and you multiplied that vector by a number, it just makes it longer in each direction. That's essentially what we're doing here. However, at times we might have a set of 2 different numbers that we might want to do, or 2 arrays we might want to multiply. So let's clear and CLC. And let's investigate. Let's say if I have the vector 1 to 10 going up like this, and let's say I have d is equal to 1 to 2 to 20, and we see that these 2 vectors are the same size. If I were to multiply a times b, we have an error. This is because MATLAB assumes matrix multiplication, and right now the dimensions of these matrices don't agree. If that sounds confusing to you, and it's been a while since you've dealt with matrices, don't worry, we're not going to go into that in this video. Rather, I just wanted to show you a common error that would pop up. Now let's say we wanted to take each element of A and multiply it by the corresponding element in B. We can do that by using the period operator. The period operator explicitly states, i.e. explicitly tells MATLAB to take each element in one vector and each element in another and do some operation with them. Now, you don't have to worry about this with addition or subtraction because MATLAB knows, or if you're operating a function on that array, we don't have to worry about that. It's only dealing with multiplication, division, or exponentiation, i.e. any time where you might have an ambiguity between multiplication of matrices and multiplication of lists of numbers. So again, to multiply indices, specific indices, within two arrays, we're going to use the period operator, which says take A, period, multiply it by each element in B, and here we are. We get 1 times 1, 2 times 3, 3 times 5, 4 times 7, 5 times 9, etc., etc. Okay, so let's just quickly recap what we learned in this video. The first command we learned is clear, which clears the screen, or rather clears the variables in your workspace. Second command we learned is CLC, which clears the screen. We learned that there are 3 simple types of variables that we defined as an integer, a float, and a string. And we also defined a new type of variable quantity called an array or a vector that could be thought of as a series of numbers that is stored in a single variable. I hope you found this video informative, and if you did, please continue to check out subsequent videos in this series on scientific programming. Thank you.